And once again, I'd like to welcome you to our webcast today, Journey to the AWS Cloud. Our presenter today is Brett Holman, who's a solutions architect here at AWS. Brett, you have the floor.
All right. Hello, everyone. Thanks for taking the time to join the webinar this morning. I'm going to take you through a journey to the AWS Cloud. We're going to talk about some of the benefits of cloud computing today. We're going to go into a couple case studies on elasticity, and then we're going to talk through a variety of the AWS services in the portfolio, and then we're going to finish off with an example of using our API set and our CLI tools, so you get an idea of how this all works. Okay, so first off, I wanted to talk to you about the AWS Mission, and that's to enable businesses and developers to use web services to build scalable, sophisticated applications. And so you see a little asterisk there that says, what people now call the cloud. So when you think about Amazon Web Services, the web services portion really means that everything we do at Amazon, all the services we make available, the ability to create services, read or list services that you've got deployed, update services or delete services is all available via our web services API. As we move through this, you'll see examples of the CLI tools in the console. And all of those things are using our APIs, our web services APIs, to actually create those resources underneath the covers. So now you have the ability to generate architecture via a nice UI, via command line tools, or potentially code or script your infrastructure out. So you're actually deploying your infrastructure via code. Okay, so everybody knows that Amazon Web Services is powering many of the big internet businesses, and here are a few couple to call out that are hallmark businesses that have grown up on AWS. Think businesses like Instagram, Dropbox, Netflix, Airbnb, Pinterest, and many others. Many great stories about building things that started very small and now are at enormous scale through the use of Amazon Web Services. One of the things that people may know or may not know yet, but we are highly trusted by enterprises as well, and we have many of the Fortune 500 and even Fortune 100 companies building out large workloads on Amazon Web Services. Companies like Shell and Unilever, NASDAQ and NASDAQ Spin Cloud, which was recently released back in 2012, are great examples of enterprises building out highly scalable applications in the cloud on AWS. So, just a point of reference here. So if you think about Amazon.com back in 2003, we were about a $5.2 billion retail business, mainly e-commerce, 7,800 employees, and you can imagine how many servers we had in our fleet. A huge number of servers and a huge amount of compute capacity to serve that $5.2 billion retail business e-commerce platform. And each day, Amazon Web Services adds the equivalent capacity to power Amazon when it was back in 2003, that $5.2 billion enterprise. So we are adding immense scale on a daily basis to the Amazon Web Services cloud. One of the other things to mention is we are completely customer-focused. Think about Amazon as a whole. We're a customer-driven company. We always innovate on behalf of our customers and listen to our customers about what they want to see from the platform. Amazon Web Services is no different. Last year, in the first 11 months of 2012, we launched 158 new features and services. So that includes things like Glacier, large-scale products like Glacier or Redshift. It also includes, new features on EC2 and RDS and S3 that people are now using today. So we're rapidly outpacing that in 2013, and we always listen to our customers and try to innovate based on what our customers are asking for most. So why are customers moving to cloud computing and adopting the cloud? There's a variety of reasons. We're going to go through some of the benefits of the cloud on these next coming slides. But one of the main drivers is the variable expense. So replacing CapEx with OpEx, or variable expense monthly. So when you think about running something on-premise, there's a large capital investment in physical installation that's required. We'll see some examples coming up here, but people are spending large amounts of money to deploy infrastructure for a particular project or to turn up a new colo or data center or whatever it might be. On Amazon Web Services, that costs $0 to get started, and you're going to pay as you go. So, hugely beneficial when you think about the financing it requires to get a project off the ground. So also, economies of scale is important. We can achieve lower variable expenses than a company can achieve by themselves. So by aggregating all the resources that are required by all these companies, we achieve an enormous scale, and all our customers benefit from that. Some examples, Samsung with their Smart Hub application, they saved $34 million on deploying the Smart Hub app. Commonwealth Bank is another great example, and Foursquare reduced their analytical costs by 50% by moving them to AWS from their own colo. And one of the things that breeds is the ability to, when you save that kind of money, you can answer questions that you couldn't answer before. You didn't have the compute and the storage necessary to save data or to answer deeper questions or to run workloads that go deeper in your data. So economies of scale allows you to, one, save money as well as to potentially answer questions on big data you might not have been able to answer before. So here's a little total cost of ownership study done by IDC, and basically what it says is there's a 70% lower 5-year total cost of ownership per app running on AWS, and they did a study. This is independent of us, and they found that the average application, the total cost of ownership over 5 years is $0.9 million, and then on-premise that would cost about $3 million to run it yourself. So, given those economies of scale, you can achieve great things inside of the Amazon cloud. Here's a little example of lower variable expenses and some of the drivers of that. So if you think about this, there's a kind of a virtuous cycle, and it's what we go through. So we get more customers, we get more AWS usage. We then deploy more infrastructure, which drives economies of scale, which then, in turn, lowers costs, which then we reduce prices, and then we get more customers, and then there's more AWS usage. And so it's a virtuous cycle that feeds itself. We've done over 31 price reductions since 2006. Most of that's not due to competitive pressure. It's because that's who we are. We are a low-margin business. That's part of Amazon's DNA, part of Amazon.com's DNA, and similarly that transfers over to Amazon Web Services as well. Very customer-focused, and we like to pass those savings down to you when we either better our efficiencies or reach economies of scale. So next, we're going to talk about elastic capacity, and that being another driver for cloud adoption. So with elastic capacity, there's no need to guess capacitor requirements and over-provision like you might have had to in the past. You can think of this in terms of deploying a data center, or you can think of this in terms of a particular application. And we'll take a look at this. I'm going to talk in terms of deploying an app, but you can correlate this to deploying a new data center or turning up a data center as well, or you're yearly planning for a data center. So here's a picture of or a graph of a typical predicted demand cycle. You need to think 3 to 6 months out about where you need to be in terms of capacity and deploy, and then it takes a while when you actually do need to deploy again to actually requisition hardware, get more floor space, more cooling, all of those things, and actually licensing that's required to turn up more infrastructure. It takes a while. So if you look at what the predicted demand is and where it is, and then you look at the actual demand for the data center, you notice that at the beginning you over deployed because you were thinking 3 to 6 months out. There was a waste, and then maybe your data center scaled or your application scaled much faster than the predicted demand. So now when you're trying to get more hardware deployed, there's a customer dissatisfaction. You can't serve them. You're either your app has been degraded, or you're not able to serve all those customers, or whatever it might be. Maybe your site is loading slower, so you're losing sales. So this illustrates well the waste that can go on, with having to guess what your capacity requirements are, as well as the dissatisfaction by not having enough capacity to scale. When you move to the cloud, you deploy based on your demand curve. So you deploy your capacity that follows closely with your demand curve, so you're always deploying just enough capacity to meet the demand that your application requires. Another key driver is the speed and agility. And I always think of this one as being the one, maybe it's not the one that people go to first, but it's the reason they move more workloads to the cloud over time and why they stay. There's a couple keys here. It's kind of leads into the next bullet as well, but speed and agility, infrastructure in minutes, not weeks. So when you want to deploy a project or a new application or start testing something, they have the ability to deploy infrastructure very, very rapidly. Here are some examples of a few companies and their quotes, but anywhere from deploying new apps and where it used to take months to days, and somebody even specifying Vantage, even specifying we can double server capacity in 20 seconds. The speed and agility, old world deploying app infrastructure in terms of weeks, whether it's 6 weeks, 8 weeks, 10 weeks, 2 weeks, it's in weeks. And, with AWS, it's literally in minutes. You can see a little mock-up of a console here where they're creating a new dev environment, a new production environment, and so on. They're doing it in Japan, and they're adding 1,000 servers. You have the capability to do that on Amazon Web Services. And, so if you think about this on-premise, you don't experiment frequently. It's more infrequently that you experiment because failure is expensive. You got to stand up an application. There's a large CapEx budget that's required to get a project off the ground, and that means that you're only going to select certain projects and only work on certain projects, so there's less innovation. In the cloud on Amazon Web Services, will give you the ability to experiment often and fail quickly at a low cost. And people may say, well, fail. Well, the more you fail and the cheaper you fail, the more you can innovate and derive successes as well. So failing quickly and at a low cost allows you to innovate rapidly and then drive more successes out of your product as well. So one of the other reasons customers are adopting the cloud is they want to focus on their business. So they're not in the, they don't need to do the undifferentiated heavy IT listing that, is required to deploy an app. There's no, it doesn't benefit their product. And, when you come to Amazon, we take care of a lot of the core infrastructure needs that you have. We're very good at doing all these things. We have great staff and we deploy great data centers. So you don't have to do these things on your own. You don't have to buy and install. You don't have to get licensing for Elasticity. You don't have to do all these things. We do it for you. And these things aren't necessarily of value to your end product. So doing them in the cloud, it's a great place to deploy your resources and focus on your business and work on your product, the things that differentiate your product. Lastly, and not least by any stretch, is global reach. So, you deploy an application and you want to have a global reach on that application. In the cloud, you can go global in minutes and reach a global audience. So, we're going to look into this a little bit more in our example at the end, but this illustrates our global footprint in your application, and the ability to go and call APIs or use our console or use our CLI tool and deploy your application around the globe in minutes with the capability well within your reach in the cloud and on Amazon Web Services. Okay, so we're going to transition a little bit into Elasticity, and I'm going to bring up a couple different case studies here. But one of the things I want to note, if you think about the cloud being a utility-based platform, you can correlate this back to the electricity industry or any of the industries like that that are utility-based. You pay for what you use. What we have done is tried to create that same type of environment for IT resources and compute and storage. So a lot of the things you think about when you think about using power equate to the cloud. You pay for what you use. You can deploy and use more when you want to. It's always there, and those are some of the tenets of Amazon Web Services. So moving on to the next slide, this illustrates a case study from Amazon.com. So this is their weekly traffic, typical weekly traffic on Amazon.com. You have your peaks during the peak times in the day, and you have your late at night. You have your times where the traffic or demand goes down for Amazon.com. Then here's the November traffic. to Amazon.com. So you can see at the beginning of the month, it starts out pretty linear, like we saw in that earlier slide. But then you can see as we start approaching the end of the month and Black Friday, we have these huge spikes, which might be 4 or 5x the normal traffic. So think about what it might require to actually run servers. So if you were deploying in the old world arena, you'd have to deploy a lot of capacity to hit these peaks. And you might have to sustain it because you're not virtualizing, your demand is not following your, or your elasticity of compute is not following your demand. So here's a picture of what Amazon would have had to provision to satisfy all those customer requests for November, and for the big spikes at Black Friday. Now, we did some math on this, and if you take a look, their utilization on deploying that kind of provision capacity would be 24%. And like we looked at on that other chart, there would be 76% waste. Wow, that's a lot of waste. So, it's pretty interesting. So what do they do? Move to a more elastic demand cycle that actually follows your, deploying compute capacity when the demand is there. And we're going to talk more about that. There's another case study, and then we're going to talk more about how you do that on our tools and on our platform. So another good use case or case study is Animoto. And so Animoto ran at about 40 to 50 servers steady state for a while. And then they launched a Facebook modification to their application, which let people share the videos, the music-based videos that they created with their content, and share it with the people that were actually in the video, so the people could see it via Facebook. They could see if they were part of this video. They'd watch the video, and then they wanted to create their own videos. So shortly thereafter, they were TechCrunched, or an article was written in TechCrunch on this particular topic, and usage just spiked. And within 3 days, they went from a steady state of about 40 servers to about 5,000 servers. Imagine doing that in your own data center. What would that take? And you would have had to plan, months ahead to have those 5,000 servers there. And then think about as well, you can see that the demand tapers off. Maybe they ran at a steady state of 2,000 to 3,000 servers after that. Well, if they had deployed 5,000 servers, there's a tremendous amount of waste again. And, guesstimating that is pretty difficult. Where is your peak going to be? So we give you the ability to do that, to burst, to fulfill your application request. And there's services that we have called auto-scaling, which we're going to talk more about. Okay, so next we're going to dive into some of the services that are available on top of AWS or Amazon Web Services. So if you think about your application and the requirements to deploy an application, every application requires co-location or a data center infrastructure. On top of that, you deploy networking between your compute and your storage and your database. Then you deploy your compute, your storage, and your database, and then you might be running application-level services that supply email or do queuing or do pub sub messaging or whatever the pieces you need are. And then lastly, there's the deployment and administration of your application. So this is a reference model of the services we offer. So we're going to dive into this and talk about what we offer in each one of these areas to help you build out your application on the cloud. Okay, so global infrastructure. Amazon Web Services is made up of 9 regions. We've got 3 regions in North America. We've got U.S. East, U.S. West 1, Northern California, and U.S. West 2, Oregon. We also have an ITAR compliant region for government workloads called GovCloud. That's government or people that are working with the government on workloads, and that's what that ITAR compliant region satisfies. Then we have regions in South America, Europe, Asia, and Australia as well. A region is made up of a collection of AWS resources in a defined geography like a metropolitan area. So those regions are made up of what we call availability zones, and an availability zone correlates to essentially a data center. It could be a very large data center or a cluster of data centers, but essentially it's a data center. That's the best way to think of it. And each one of these is designed as independent failure zones. So they're spread around a typical metropolitan area, but they're not necessarily located right next to each other. We try to keep them physically separated and separate faults as much as possible between availability zones. And you can think about building applications, across availability zones in a region. When you actually build out your applications in multiple data centers, you've got single-digit milliseconds between, low single-digit milliseconds latency between these availability zones. So it's very possible to build out applications that span multiple availability zones on the Amazon cloud. Lastly, we've got edge locations, and this represents the edge locations where we host our content delivery network or our DNS Route 53 network. And we'll talk more about these two products and how they lay over this network, but needless to say, there's about approximately 40 edge locations in the network now, and that number is always growing. Okay, so we're going to dive into the networking stack on Amazon Web Services. So the first product we're going to talk about is Route 53. And so Route 53 is our highly available DNS service. It's supported globally. There's edge locations around the globe. It has the ability to scale based upon usage. So based upon your query volumes for your particular host zone that you host in Route 53 for your domain name, it'll automatically scale based upon query volumes. You have the ability to deploy multi-region applications and use something called latency-based routing, where when a user requests your DNS record, it will send you to the nearest regional data center to actually terminate that traffic, so you can host in multiple regions around the world, and Route 53 will route you based on your proximity to the closest data center, or the closest availability zone, or the closest region where your application is being hosted. Lastly, it's secure. It integrates with IAM, and you also have API access to this. You can add records. So let's say your application is producing custom subdomain records for a particular client that signs up for a service. You can do that via API. You can make API calls to Route 53, and on demand, your application create new records, new custom CDN records or new custom DNS records, or update DNS records on the fly. So next, we're going to talk about virtual private cloud, and very popular product on AWS. So virtual private cloud, I think the best way to describe this is this gives you the tools that you require to build out your own virtual data center on Amazon Web Services. So you start off by picking an IP space, and you pick your own IP space that you want to use inside of your cloud. Then you subnet out that IP space. You deploy subnets. You can deploy ingress-egress rules around those subnets, and what kind of traffic can come into and out of a particular subnet. So that provides some level of security about what you're going to deploy in each subnet, whether it's going to be database servers or web servers. Then you can specify the routing rules for a particular subnet, and then what access they have to the external world. Where does this traffic for the subnet route to? Does it route out back to your corporate data center over a private connection, or is it allowed to route out to the internet? So you have all these fine-grained controls for deploying a virtual data center on Amazon Web Services inside a virtual private cloud. We're going to talk about a couple of the means for connecting your virtual private cloud or your Amazon data center to your own corporate data center or network. So the first way you connect your VPC to your own corporate data center would be via a VPN connection. So we have endpoints. As part of when you stand up a virtual private cloud, you can provision something called a virtual private gateway, and on that virtual private gateway, you can terminate IPsec VPN tunnels that go back to your own router or firewall or customer gateway. And so one way to connect, a quick way to connect your virtual private cloud up to your own corporate data center is with VPN connection. There's another way, and typically customers will start off with VPN connection or IPsec tunnels, and then they'll, as their workloads grow and there's more data moving back and forth between their virtual private cloud or their virtual data center on Amazon Web Services and their own data center, they will purchase a private connection to Amazon Web Services, which is called Direct Connect. And Direct Connect comes in two flavors. You can purchase a 1 gig or a 10 gig port into Amazon Web Services Cloud. And then once you've done that, you got the ability to create VLANs over that. So you can create VLANs that connect your data center up to your virtual private cloud privately, or you can have a public VLAN as well, which allows users on your network to communicate without going over the public internet. You're going over the public space on a public VLAN, but you're hitting Amazon Web Services APIs, calling S3, retrieving objects, doing all the things you might want to do in the cloud publicly over your Direct Connect as well. So you can sub-interface that Direct Connect into multiple private and public VLANs. Further, how do you get to us? Well, there's a variety of means. There's about a dozen or so sites around the world where you can come and meet Amazon Web Services. We've extended our network out to those locations called Direct Connect POPs. And so you either, one, may be co-located in one of those Direct Connect POPs, and then you simply buy a cross-connect from the colo provider to Amazon Web Services at the gig or 10 gig rate. Or if your data center is not sitting in one of those co-location facilities, you would purchase a third-party circuit from one of our from a telecom provider to extend it out to one of those facilities, and then you get a cross-connect over to Amazon Web Services at the gig or 10 gig rate. So next, we're going to move over into the compute stack, and first thing we're going to talk about is Elastic Cloud Compute. Now that is really, one of the flagship products of Amazon Web Services. When you think about virtual service in the cloud, that is EC2, and there's a variety of instance types. You can deploy servers for anywhere from a micro size all the way up to what we call a cluster compute, and we refer to these as instances. So we don't call them virtual servers; we call them instances. You deploy an EC2 instance, you choose your size, anywhere from micro to cluster compute, like we discussed. So, Elastic Cloud Compute or EC2 is very flexible. When you launch an instance, you can choose to run on Windows or Linux. You got the ability to scale from micro to cluster compute. You can deploy many at a time as well. You always start from what we call an Amazon machine image, or an AMI for short. And an AMI can be anywhere from a base image of an OS, like Windows 2008 R2 or Linux CentOS or whatever it might be. And you start from a base AMI, or you can choose an AMI that somebody's put out there that has a variety of other packages installed on top of the base AMI. Like in the case of Windows, it might be IIS and SQL Server Express already deployed on an image. When you launch an image or launch an instance, you have full control. You own that guest OS. You have the full root or administrator rights to that box. You get a pair of keys, you launch the server with those keys, and you access that server with those keys, and we do not have those keys. So you are the owner of that instance. So it is secure. And further, when you launch an instance, you deploy an instance inside of a security group. You always launch a server inside of a security group. By default, before you modify the security group, all security groups come by default with no ports and no IP addresses open for any services. And so you launch an instance. As you open ports and IP address ranges on those ports, now you can start doing things like SSHing or RDPing into your instance. So you open up a security group, and by default, that security group is a blanket deny. So that it is very secure. Also, you have the ability to monitor. We publish metrics to CloudWatch that come out of a hypervisor. Things like CPU utilization and other metrics you might want to see are available via CloudWatch, which is our monitoring tool, and we have a console for that as well. There's a variety of ways to purchase EC2. You can do it on demand. That's the utility-based model. We also have a reserve model where you pay a little bit up front and you buy down your rate and save well over the life of the contract. And lastly, you have the ability to bid on the unused capacity that exists in an Amazon data center at any given time. And you can obtain great savings by using these spot instances to purchase capacity for doing batch-type workloads or Hadoop-type workloads. Lastly, you have the ability to use our VM import and export tool to import Windows images into AWS. And if you've imported a Windows image, you have the ability to export it back to your own data center as well. So next, we're going to take a look at an example of launching an EC2 instance. So we talked about the Amazon machine image. You always pick an Amazon machine image. Again, we'll use the example where you're choosing a base OS. But you could also choose from many images in our the EC2 AMI community, and there are literally tens of thousands available. Then you launch that instance. You choose what instance type you want to launch it on. Next, you decide whether you want to launch it in the public or private cloud. You then choose which availability zone you want to launch it in. Then you go and you create EBS volumes, which is our block storage. We're going to talk more about that in the coming slides. Then you can snapshot those EBS volumes. And I think the final point to make here is that you launch from a base AMI, but once you've deployed all of your software on a particular EC2 instance and you've deployed your source code, you've enabled services like on IaaS or Apache, so everything is running. Now you can snapshot that particular instance. So and then you can relaunch more images that look exactly like that, with everything deployed and just ready to go. We're going to talk more about that in terms of auto-scaling a little later. And when I say a little later, I mean the next slide. So auto-scaling. So what this gives you the ability to do is set up a set of compute resources that are going to scale out based on the items you require in your clusters. So the way this works, you set up an auto-scale launch configuration, which specifies what you want to launch. So I want to launch a server of this size with this particular AMI, and your launch configuration, you can pass in user data for bootstrapping, do a lot of different things, inside of your launch configuration. Then you create an auto-scaling group. An auto-scaling group says, I want to always be running a minimum of 4 servers. In this case, this is just an example, a minimum of 4 servers and a maximum of 200 servers. And I want to launch them in this availability zone or these availability zones. So you can have this application running across multiple availability zones. You can also have these things attaching to a load balancer, or registering and deregistering with a load balancer as part of autoscale. So lastly, now that you've got this min size and max size, you either deploy a policy to scale on a metric like CPU utilization. You might say, I want to scale up when my CPU utilization is over 80% on average for over 10 minutes, and I want to scale up by this many instances. And when my CPU utilization is below 40% for over 10 minutes, I want to scale down by this many instances. Further, you can also do this on schedule. So you could schedule at certain times of the day where you know you're going to have a huge spike in traffic and you don't want your application responding to those huge spikes. You'd rather scale ahead of time. You can use something like auto scale by schedule. Say at 5 p.m. I want to scale up, from 4 servers to 200, and then at 10 p.m. I know my traffic drops off drastically. I want to scale back down to full. So next is our Elastic Load Balancing product, which I mentioned earlier, and it's often shortened to ELB. And it's a highly scalable load balancing application. It distributes load across multiple EC2 instances in multiple availability zones. And some keys to this: one, it works in conjunction with autoscale if you choose. You can use it separately, but you can also use it with autoscaling. And it will automatically, autoscaling will automatically register and deregister instances from it as autoscaling adds them to the fleet of web servers or app servers or whatever it might be. Also, Elastic Load Balancing scales on its own based on traffic, so it will deploy more resources as traffic scales, and will also shrink down as traffic cools over time. You can always use this to spread traffic across multiple instances in multiple availability zones within a single region. So very powerful. It also provides health checks, which you can configure, which will health check an instance and then remove unhealthy instances out of the fleet and stop sending traffic to them until they start passing health checks again. So that's powerful. You set up the health check when an instance starts degrading. It will remove it from the load balancer and stop sending traffic to it until it actually starts passing health checks again. Another thing, we always recommend, when you're building out a new app, if you can, separate session state from your application and store it outside of your particular server. In a key value store and Memcache and DynamoDB, a variety of different locations you can store your session state in a database. But many applications store user session data right on the server. So ELB does support session stickiness as well, or session affinity, where it will route requests to the same instance if you set up this session stickiness or session affinity. So it'll always send the same user back to the same server. And that can be important if you're storing session on the server. because you don't want the user to have to log in when they end up at a new server. Lastly, just to round out Elastic Load Balancing, it does support SSL, and it also does publish metrics to CloudWatch. So next, we're going to move into the storage part of the stack. And our first service we're going to talk about is Simple Storage Service. So S3 is a durable object storage. It has 11 nines of durability on objects. And you might say, wow, 11 nines, how does that work? Well, when you upload an object to S3, that object is replicated around the region. So there's multiple replicas of that object available around the region. And then we deploy algorithms to keep check on those objects to make sure they don't degrade. And if they degrade, we'll destroy them and regenerate them from a clean object. So very highly durable storage. And also it's unlimited. I mean, you just keep on uploading, you pay for what you use. You can store up to 5 terabyte objects. And the way this works, you create buckets. And, a bucket acts like a drive. You can deploy folder structures within a bucket. This is not a file system, though, and that's one of the things. This is an object store. Then, you can deploy access control over your buckets or your objects. You can specify who is allowed into a bucket or who's allowed to access an object and who's not. And you can create users via IAM that allows certain, users into the bucket to put things, and maybe a different user that's allowed to get things out. You also can use IP addressing in a variety of different ways to, manage access control. On the encryption side of things, you can always use SSL to upload objects, so you get encrypt your data in transit, and then you can also encrypt it at rest with our server-side encryption. Further, you can pre-encrypt prior to uploading to the cloud as well. Supports multi-part uploads, so if you're uploading very large objects, you can do a parallel upload. Supports versioning. You can expire objects out and remove old ones. We're going to also talk about the ability to transition objects. So we're talking about our simple storage service now, but in a few slides, we're going to talk about Glacier, which is our cold storage solution. And you have the ability to push objects into S3 and then set up a transition policy where maybe after 30 days, a particular object gets retired or transitioned over to Glacier for a long-term storage. You can set up access logging on who goes into a bucket or an object and who grabs it, who does what. You have the ability to access log and put those access logs in S3. You can also host content out of S3. That can be static content from your website, from your own custom origin, or you can actually host an entire static site out of an S3 bucket. Lastly, you've got the ability to use our AWS import-export service. So if you've got a large amount of data and you don't want to upload it via the internet, you can actually send us drives via this import-export service. Okay, so Spotify. Many people are familiar with the Spotify application. The ability to create custom playlists, share music with friends, lots of great capabilities of this application. Got a huge content library. And they needed a storage solution that could scale quickly without incurring long lead times. They need to be highly durable. They found Simple Storage Service, and they're very happy with Simple Storage Service, and they do host their library on S3. So next, we're going to transition into our Elastic Block Store product. So when you launch a server in EC2, and you want to mount a persistent drive that will live beyond the life of that particular EC2 instance, you would mount an Elastic Block Store drive. So it's a high-performance block storage device. It can be anywhere from 1 gig to 1 terabyte in size. And so you basically would create the volume, you mount it to a particular instance, and then you can format it once it's mounted. You can also RAID, use software RAID to RAID together multiple drives or multiple block storage volumes. And secure and private to your instance. You can actually specify performance levels you want to achieve with EBS. You can specify I want to deploy a 1 terabyte volume, and I want it to have up to 4,000 IOPS in performance, and we will create a volume that can achieve that kind of I/O. Also, it has a good availability built into the solution. We actually replicate that volume to another volume inside of the availability zone. So when you've got a primary volume, you also always have a volume that's being replicated to in case something would happen to that primary volume. You also have the ability to snapshot those volumes, which I showed you in the EC2 slide earlier. and then store those snapshots in S3, which is highly durable. And one of the things to note is if something were to happen to that particular volume, you'd always have the ability to launch that from a snapshot in any of the availability zones in a region. And lastly, you can actually monitor these drives with CloudWatch and see the metrics in terms of I/O and a variety of other metrics. Okay, I'm going to briefly talk about Glacier, and we mentioned this earlier as well. Glacier is our lower cost storage. It's great for backup and archival. It's for data that you don't frequently access. It's meant for long-term storage. Comes in at a very low cost, around a cent per gig per month with no upfront commitment. It has the same durability as S3, and further, you can store data in S3 and then transition to Glacier. And then you just simply go back to the S3 console after you've tiered it off, and you say, I want to restore this particular file from the S3 console, and it will pull it back to S3, and you can set up a notification so you know when the object's back and restored. API-based, very secure. You can use import and export to get data in here, and if you're using it natively, you create vaults. It's very similar to an S3 bucket. Okay, now we're going to transition to the database area of our stack. And our first service, so you can always run databases on EC2. Run your own database, roll your own database. You can use any database technology that you want. But we also offer a database as a service product called Relational Database Service, or RDS. And essentially what it is, we offer a variety of different platforms, MySQL, SQL Server, or Oracle. You do launch the native MySQL, SQL Server, or Oracle versions. You get to choose which version you want to launch. We recently just released 5.6 for MySQL. It's going to launch it with the kind of the standard sensible default settings out of the box. You can set up automated patching and how long you want to keep, or when you want the automated patching to happen. You set up your maintenance window. You can also set up automated backups. You can use point-in-time restore. You can specify how long you want to keep backups and so on. You can provision I/O similar to EBS. You can specify how much I/O you want to provision. And Oracle and MySQL can handle up to 30,000 IOPS, or 30,000 IOs or reads and writes per second. It also has a built-in failover solution where you can set up a master-slave environment with a master running in one availability zone and a slave running in a second availability zone. And then it will automatically fail over from master to slave with about a 1 to 3 minute failover time between master and slave. And lastly, if you're running MySQL, you have the ability to launch read replicas and separate the reads from your master database so that reads are going against read replicas you create, and writes are going against your master. We also have a NoSQL offering called DynamoDB, it's a key value paired NoSQL database. It's got fast and predictable performance. And when I say that, you have the ability to dial up or dial down how much read and write capacity you want. So you could say, to start off, I want 20 reads per second and 10 writes, and it will actually provision the right resources given your amount of data to handle 20 reads and 10 writes per second. But then as your application scales, you can twist that dial. And people have twisted that dial to extreme, highly, scalable throughputs. Things like, over 100,000 or in the 100,000 range of, reads and writes per second. And so it can scale to enormous proportions. All the data that you put in DynamoDB is replicated around the region. So there are multiple replicas. So any servers running in any of the availability zones in the region can call their local API endpoint, and the data, will be retrievable in single-digit milliseconds in those availability zones. And so everything is SSD backed and very fast. Also integrates to CloudWatch. IAM is built in, so you can specify who has access to a particular table and who doesn't, and for what types of purposes. And lastly, it integrates with our Elastic MapReduce and Redshift products. So it's tightly integrated with those two. Next is SQS, our simple queue service. So it's a queuing service. We also have a messaging service called SNS, which is publish, subscribe messaging, or a version of that. And the queuing service, why would you use a queuing service? Well, let's say I want to build an application and I want to decouple certain components from the front-end experience. So let's say I've got a user uploading videos. I may have a user upload a video. Once they upload it to the server, I'm going to push that video to S3. and maybe I need to transcode this video into different formats. So I'm going to send a message over to S2S saying, hey, there's a video in S3 that needs to be transcoded. And now my web server continues on the workload. We're processing the user request and responding back to the user that their upload is complete. But I might have worker agents that are polling that queue, that transcodes queue, to go and grab the video, the URL for the video in S3, and then potentially go and push it through our Elastic Transcode service, or to use an API-based service from one of our partners, or three, potentially run their own FFmpeg transcoding on EC2. Any of those possibilities exist. They use the queues, so they decouple the back-end work of transcoding from the front end where the user is doing the upload. So it's a reliable service. Scales as you need to. Messages are replicated around the region and available from any endpoint. And it's secure. You actually use APIs with your access key to get messages out. Very simple APIs to call to send and receive messages. Cloud Search is another service that it's based on the Amazon A9 search engine. It's a Elastic search engine. It's fully managed, lots of sophisticated features. It scales based on the number of items you add to the index. Your document server will scale based on the number of documents or items you add into the index, as well as it will scale based on the number of searches that are being done against the server from users. It has some very sophisticated features, such as faceting, stemming, giving them stop words. You can also write custom rank expressions. So really great way to deploy a search engine, integrate it into your business, and do it very rapidly. CloudFront is our global CDN. Like we talked about, there are somewhere around 40 edge locations available, and that's always growing. So what it does is it provides a caching mechanism for your overall application or delivering your content. So let's say you have users around the globe and you're trying to get that content as close to those users as possible. CloudFront would be the product that you'd want to use. There's three different use cases. There's maybe the static content where a user requests your web, contacts your particular web application. Your web application says, please download all these pieces, the images, the videos, the CSS, the JavaScript from CloudFront. And then when it calls CloudFront to get them, it retrieves them from a very local cache node. Second use case might be putting CloudFront in front of your website. And we call that dynamic site acceleration. So CloudFront proxies all requests back to your actual web application. So in this example up above, in the reference architecture, you can see it getting images out of S3 that's using, there's multiple origins, and there are different cache behaviors. So if the request has images slash in it, images slash star will get them out of S3. And it'll cache them locally, and then they're locally cached and available to users. For things that go back to your custom origin, it will actually do TCP optimization between the CloudFront edge and your custom origin to actually get your dynamic content that calls back to your web app and your database broker them quicker with TCP optimization between the CloudFront edge and your application. The third way to use CloudFront is for streaming services such as RTMP, where you can stream objects directly out of an S3 bucket. People also do live streaming with Adobe Media Server and Microsoft Media Server. So many streaming options available as well from CloudFront. Next, we have a managed Hadoop offering we call Elastic MapReduce, or EMR, and allows you to build an Elastic Hadoop cluster and launch it very rapidly. This product integrates tightly with S3 for storing the data, ingesting it into Elastic MapReduce, processing it, and putting it back into S3. So it's great, highly durable place to store your data for processing and then after processing as well. It also tightly integrates with DynamoDB. You can write Hive queries that actually will go and query the SQLite statements off your DynamoDB table. It's very scalable. You can turn up a cluster. You can add nodes. You can use spot instances to augment. Very cost-effective and easy solution to use from running your own custom Hadoop cluster on EC2 or in your own data set. Okay, we're going to touch on the deployment and administration tools. So here we're going to talk about something called Beanstalk, Elastic Beanstalk. So what Elastic Beanstalk is it's our app container. It allows a developer to not worry about the infrastructure required to run a web application. We take care of that for you. All you need to do is write your code and use a variety of tools such as Eclipse, Visual Studio, or Git to deploy it to a particular application. And we support .NET, PHP, Java, Python, Ruby, and Node.js. We automatically create the load balancers, the instances behind there. We set up auto scaling and all the monitoring. We'll aggregate logs off the instances and push those up to S3. You have the ability to create multiple environments for an application, so you can create a dev environment with a specific URL for dev, a test environment with a specific URL, and a production application. And you can deploy different versions of code to each one of those environments, and you can easily roll back deployments as well. And lastly, the really great thing about this is you have full resources, or full access to all those resources. So you can still take your SSH key and log into the instance, or your or RDP into the instances, and gain access, troubleshoot, do whatever you need to do inside of an instance. So very powerful. Next in the deployment integration tools area is CloudFormation, and what this is, it's a scripting framework for creating AWS resources. And you can create resources inside of our JSON scripting environment, and you can deploy them in stacks. So you can deploy a whole application as one template, JSON template that you write out at the push of a button or using CLI or API commands. Really cool. You can pass in parameters, so you can say, well, I want to create an application, and here's the script for my application. But I want to, for dev, I might only want to run one instance on a small. For test, I might want to run two instances in two availability zones, and I want to run, small. And then in production, I want to run 20 instances on extra larges behind the load balancer. So you could have the number of instances and the size of the instances passed in as parameters. And you can define what you want to pass in as parameters, but when you lay out the actual CloudFormation stacks and scripts. It's a very powerful tool. Also, we have identity access management, which allows you to create groups and roles, assign permissions, and then assign users to those groups. We also have a variety of SDKs that wrap the RESTful APIs that we expose for each service into some very commonly used things for each service. So you don't have to use the very granular APIs. You always have the ability to do that. But if you use the PHP or Python or Ruby SDK or any of the SDKs, it will group things like I want to put an object in S3. So a simple call to do that, and so on. Okay, so there's many other services that we have on our platform. I would highly recommend you go out and learn more about email services, workflow, notifications, caching, and so on. I'm going to mention a couple things about two other services that were recently launched. We recently launched Redshift, which is our petabyte scale data warehousing solution on Amazon. It comes in around a tenth the cost of traditional data warehouses, and it has the ability to you launch it very easily. There's a couple of buttons, knobs you can twist. You can always add nodes to the cluster to grow your cluster out. It can start out very small and grow to up to 1.6 petabytes. And it's very compatible with popular BI tools and different tools you use for querying and access to it. We also have Elastic Transcoder, which we just recently launched. So what this allows you to do is, we used the video example earlier. Let's say I've got that video item in a queue that I want to transcode. I can call Elastic Transcoder. What I do is I define a pipeline, and it specifies what the input bucket is for my content and what the output bucket is. Then I define a preset, which says, when I run a job, I want to run it with a particular preset, and this preset is going to create a 1080p MP4 output, let's say. And then next, I create a job, and I say I want to run a job on this pipeline with this particular preset or treatment, and the output will be put in the destination bucket, and from there I can start serving that content. Very powerful tool compared to rolling your own transcoder inside of EC2, but many people might want to do that as well. Okay, so we're going to run through a quick use case, and then I'm going to open this up for questions. So this is on utility computing. There are many different types of things you might do on utility computing. You might run a database. You might run a load balancer or a workflow, or you might just be using it for running web servers. And many benefits for doing utility computing in the cloud. So we talked about our region. We talked about how availability zones exist inside of a region. And we also talked about, so when let's say I wanted to launch resources using our CLI tool. I've got the ability to go global in minutes. I talked about that earlier. Well, here's a couple API or CLI calls using our command line interface calls to launch EC2 instances. And this is going to launch with this AMI. It's going to launch 3 instances of EUS1A that are M1 small right there. And I'm going to run another CLI command, which is going to launch 5 instances of EUS1C that are medium. Very easy to do. I just launched 8 instances, and I can bootstrap my applications on those launches as well. Or I can be launching AMIs that are golden that already have all my data on them to launch that particular application and run it. Next, I can go launch some in North America. I'm going to launch 2 in US East 1B and 2 more in US East 1B. Next, I'm going to create a load balancer. I'm going to authorize ports over in Europe, and I'm going to create an auto-scaling group. So this shows you the power of the ability to launch resources very rapidly and provision what you need when you need it. Just the same, you can list your resources, you can update them, and you can turn them down via the console, via the command line tools, or via the APIs. This is a brief look at the console. So the console has a rich set of console-based services for doing similar things that I showed you in that last example. And we come to the summary. So, we talked about why customers are adopting cloud computing. I mean, many reasons: variable expense, reaching economies of scale they couldn't in their own data centers, and benefiting from those. The ability to use capacity elastically and match your deployment curve to your demand curve. The speed and agility you can reach for deploying new projects. The ability to fail fast and innovate quickly, and fail cheaply and be able to innovate more. Focusing on your business. And lastly, going global in minutes. Thank you all. I'm going to go to Q&A now. We've got a few minutes available for Q&A, so I'm going to move over to that, and I'm going to try to answer a few questions. All right. Just give me 1 second here. So somebody asked, what type of hardware is used to create the VPN connection between our local network and our Amazon VPC? From your end perspective, you can run any router or firewall or endpoint. It could be a virtual appliance as well that can support IPsec. There's a set of requirements on our in our VPC guide, and then on our end, it ends at an appliance on our end that terminates those connections, for your particular VPC. So you can use anything on your end, and on our end, we've got an appliance, that you're going to be terminating connections to. And if you run dual tunnel, you terminate those at dual appliances on our end. Can you suggest some of the better resources for continuing to learn about AWS? What I'd recommend is this. We have a white papers area. If you go to aws.amazon.com/whitepapers, there's a great deal of white papers that dive into particular solutions that are available on AWS. Best practices for architecture, best practice for running a database, and so on. Many different topics you can find white papers on. We also have an architecture center. So if you want to learn more about architecture, you saw some reference architectures in the slides up in the upper right-hand corner when we were going through the different services. Well, we have an architecture center. It's at aws.amazon.com/architecture, and you can see different architectures for batch workloads or for content delivery or for running a web application that's highly available. And all those are available there. So I'd recommend going up. And then lastly, if you want more documentation on each one of these products, go to aws.amazon.com. From there, you can navigate to the product. And on the left-hand side of every product page, there's a link for documentation. And the documentation link will take you to all the developer docs, the user guides, and all of that to drill down deeply into these products and how to use them. There's usually a getting started guide as well. So it'll be a very easy, process to get started, in very short amount of time. And then, the nth level of detail you'd want to go down to on using the APIs and whatever you might need to do. Somebody asked, do we have a one-click deployment for Drupal? So what I'd say is we've got one-click deployments available. If you search AWS CloudFormation, you'll find quite a few different templates available that are one-click launches of a variety of different application stacks on top of AWS. So like I told you, you can script out your own environment, but we also have a lot of pre-built ones that are easy to launch. So I think, see if we can do one more question here. So the question was, you mentioned Windows and Linux AMIs. What flavors of Linux are available? So I'm not sure if I'm going to hit them all, but I'll mention a few. So we've got Amazon Linux. We've got Red Hat Enterprise Linux. There's SUSE Linux, CentOS, Ubuntu, and I'm probably missing one or two. We also support Windows 2003, 2008, and 2012. All right, so I think we're to the top of the hour here, or to the bottom of the next hour. So thank you all for coming. I appreciate your time, and watch. There are many more other webinars coming out on different topics, such as high availability applications. Thank you very much. Bye.
All right, thanks so much, Brett, and thanks everyone for attending today. I would just like to remind you to please take a second to fill out that survey. You just let us know what you thought of today's webcast. Thank you so much.